Hello, this is going to cover Standard 6, which is on pointers. It's 10% of your grade. You will have a program, one program to do when you're done, or you could incorporate pointers into a current program if you would like. If you incorporate it into a current program, please submit it here so that we know that we're grading it for the pointers. And mostly this is an exposure chapter, but you will have the one program to complete. So we're going to start with in Gaddis. It actually covers chapter 10, and there are parts of chapter 11 that cover a little bit of it. I am going to focus on chapter 10 PowerPoint slides and talk you through. And so you will want to, if you want to take notes, you're going to be able to use one sheet of notes on your final exam for each chapter. You could use this for part of your notes. So you've been working with arrays, and you have probably noticed with arrays that they are not the easiest thing to work with sometimes, and they're not very malleable is what I would call it. And so in C++, we have something called pointers, and I already introduced some of you guys to the idea of vectors, and vectors uses pointers kind of behind the scene a little bit. But pointers are used to help make the language more dynamic. Those of you that are familiar with Java, you will know that there's something like array lists that grow and shrink, and that's what a vector does also. It grows and shrinks, or is capable of growing and shrinking, unlike an array. The other thing about pointers that we'll talk about is pointers is actually what makes arrays work. And so sections 1 through 4 here are going to be the most important. You'll probably need section 5 maybe a little bit for your program, and we may or may not get to section 6 here, okay, and some of the others. But we're going to go through this fairly quickly. In C++, you have something called the address operator, and the address operator is the ampersand. We use that for a couple other things, but in this instance, when we have a single ampersand, it is to get the address of a variable, which is why when you pass a value by reference, you use the ampersand, because you're actually passing the address of the variable, not the actual variable. So in this particular case, if I have ampersand num, it's the address of the memory location that's a pointer, and it prints the address in hexadecimal form. I don't know if the next slide will show that, but that's what it does. In order to save a little bit of time, I'm not going to be demoing a lot of these. I'm just going to be talking about them, but feel free to try some of that on your own to see how that works. A pointer variable is a variable that holds an address, and it's an alternative way to access memory locations is what it amounts to. So in this example here, we have an integer, and they name it int_ptr for integer pointer. And asterisk will hold the address of an integer, and the int_ptr, integer pointer, points to has a type of integer. And so the spacing does not matter. You can have int asterisk then the variable, or you could have int asterisk spaces and then the variable. So it doesn't matter where these spaces are called. This asterisk actually has a name. It is called the indirection operator. So if I were to write a program and I assign a variable num25, and then I create an integer pointer, and then I assign integer pointer the reference to num, that's what the ampersand is a reference. What I'm doing is actually assigning the address to where this variable is stored. So these two are linked. I can access the value using integer pointers and the indirection operator. And so if I output the integer pointer itself, I get the address. If I use the indirection operator in front of it, it actually prints the value that's stored at that address. And so this is often called, and they'll talk about this in the PowerPoint, I think, dereferencing the pointer. So when you use an asterisk, you are dereferencing the pointer and printing the value to which it points to. When you're working with arrays, the name of an array is a pointer. We haven't told you that before, but that's also why when you pass an array to a function, you can just send the name, because all you're doing is sending the pointer. And so the starting address of vals is at, this is hexadecimal, 0x4A00, and if I output any array name, you can try this in some of your programs, it's going to output the hexadecimal for wherever that is stored. So what it does is it points to right here. the beginning of the array is the address to where that section of memory occurs. And remember that arrays are stored contiguously in memory. That's going to be important here in a minute, but that means that they are stored one right after another in memory. They are not separated. So an array name can be used as a pointer, and if I want to dereference a pointer, dereference vals, it's going to display the first item because the name of the array points to that first index or index 0 in the array. You can also use a pointer to be an array name. So I could have vals is assigned to a integer pointer. And so if I output val pointer bracket 1, it's going to display 7 because that's actually at index, this is index 0 still, this is index 1, this is index 2. If I were to output val pointer 2, it's going to display 11. When I work with pointers, let's say we have this vals, so when you guys do your program, you'll have to declare an integer array or whatever type of array that you have. A lot of them are integers. You still need to declare the array, and you can just fill it on the fly. You don't have to worry about writing a loop to fill it if you'd like, meaning you can create the array and you can fill it here. And then we're going to create a pointer to the array. And then we're going to use the address operator and the fact that 1 times the size of an integer in order to move through the array, which means this. If I use my indirection operator here and I want to get the value that's in the array, if I just display, remember if I display asterisk val pointer is going to display the 0th position. If I take that val pointer right here and I add 1 to that, what that is essentially doing is just moving from index 0 to index 1. So it moves to the next item. So this is what we call pointer arithmetic. I'm using math or just adding to get to the next item. If I add 2, it's going to display 11 because it's moving to the next index. And so it's saying I'm going to start counting at this position. That position is position 4, the first item, and I'm going to add 1 or I'm going to add 2 to that. And that's why arrays have to be stored contiguously in memory, because the pointers actually use this behind the scenes to get to all those values. You must use parentheses when you do this, and it won't display the actual value unless you put the indirection operator in front here. So you have to dereference that pointer is what we call that. And so here's just a table that reviews what I just talked about. So you have an array name and a subscript in arithmetic. You have a pointer to an array and a subscript arithmetic as examples here. When you access an array, we use brackets for array notation. When we use a pointer, you use parentheses, and then you have to add the index here that you're wanting to get to. There are no bounds checking, so you could also get out of bounds errors. Pointer arithmetic is that idea that you can increment or decrement operators, and one pointer can be subtracted from another pointer using the subtraction operator. So I can use val pointer plus plus, and that's going to just move from the name, or move from wherever position it is on to one position to the right. If I do plus plus, and if I do minus minus, it moves one position back to the left because arrays are stored contiguously in memory. Also on pointer arithmetic, this is when the comments on your program that you guys are supposed to do, it says to use pointer notation whenever possible. This is what we're looking for. We want you to use pointer notation to output the array elements. And so you'll probably hard code the values that get filled into your array, or you could maybe have the user input them, but then you're going to output them with pointer arithmetic. That's the gist of the program that you guys are going to write. Okay? And they do have some more examples here. You can use plus equals as well. So everything that you can do with regular arithmetic, you can do with pointers. Just understand what it's doing is it's saying I'm going to start here and I'm going to add consecutively to that position from my starting point. And my starting point is the first position, or the 0th index. They have some more examples. You can go through the PowerPoints here. If you create a pointer and you don't assign it a value to start with, you can initialize it to null or 0 if you'd like. You can initialize to an address of another variable, so you can assign a pointer to the address of another variable. The initial value must have the correct type. So if I take an integer pointer and I try to assign it the address of the cost variable, which is a float, that won't work. You'll get a type incompatibility error. You can compare pointers using double equals. And well, two things. If I use this pointer to pointer, it compares the addresses. It checks to see if they are in the same memory location. Versus if I dereference the pointer, then it's going to check the value that's stored inside the array. And then pointers as parameters. A pointer can be a parameter. It works like a reference parameter to allow changes. A pointer parameter must explicitly dereference to access the contents. So if you're passing a value, you can pass in an integer pointer. You can see in the pointer and the address as the argument to the function in the call. I'm going to get num ampersand num. So the asterisk on the parameter must be in the prototype. So this is your prototype line. And you could actually, you could just do int, I believe, just asterisk. You wouldn't need the PTR. The asterisk has to be in the body to dereference the pointer. And then the address to the function call has to pass by with an ampersand. So you have to pass by reference. So this would be a little bit different here. When you call the method, you have to use the ampersand. Okay? You do not have to modularize your program that you're going to write for this particular assignment, so you don't actually have to worry about passing the parameters. But if you have been a little bit weak on doing some modularization, this would be another way for you to get some updates to your modularization standard. And so they give you some examples here. Pointers to constants and constant pointers, we really don't address this particular issue, but the idea there is that it's kind of like making a constant array or passing in an array with the constant keyword because maybe you don't want to change something. And so if you can have a constant pointer, which is just the idea that you're not going to change the values, and so you want to protect the data. Okay, but that is not something that we are going to emphasize. Dynamic memory allocation is something some of you might want to use in one of your programs, your bigger programs for the inheritance. And so you can allocate storage for a variable while the program is running. This is the way that you could actually create a new array while the program is running. But you use the new operator to allocate memory. And so the new returns an address of the memory location. So you declare a variable, a double pointer, D for double, PTR for pointer, and then you assign it a new double of that data type, and it creates memory on the fly. It is often used to do memory allocation for an array. So this is how you can actually create an array on the fly, is have an array pointer, and you're just going to create a new array of doubles, size 25. And if there's not sufficient memory, the program may terminate. You can use the brackets then instead of pointer arithmetic to access the array if you do this. And so they're showing you how you can use the bracket notation to do that. When you guys write your code, though, for this particular chapter, we do want you to practice the other pointer arithmetic. But anytime you create something dynamically in C++, you have to manage the memory. So you have to make sure that you delete the array pointer when you are done. And you only use delete when you have dynamic memory. Dangling pointers and memory leaks we are not going to address, but that all deals with this idea that if you don't release this memory at the appropriate time, if you leave it hanging out there, so to speak, then you could cause a memory leak. You can return pointers from functions. The function must not return a pointer to a local variable in the function. So you can't create a local variable within the function and then return a pointer to that, because the function, once that function is done, that variable no longer exists, and that creates one of these memory leaks potentially. Okay, so make sure that it's a pointer to something that was existing outside the function. You can also have pointers to structures and class objects. And again, we are not emphasizing these sections, but just want to show you that it is possible. So I could create a student pointer, and I'm going to have a new student. Square pointer is a new square, and then I would make sure that I have to delete the square pointer or delete the student pointer when I was done. Structures, objects, pointers, and function parameters. And so pointers to structures or objects can be passed as parameters. Such pointers provide a pass-by-reference parameter mechanism, and pointers must be dereferenced in the function to allow access to the memories. So you have to use that asterisk operator to dereference them. And again, just remember to use new. If you use new, you have to use delete in order to take care of memory. This particular slide shows how to access member objects. If you have member objects, you actually use this arrow notation. So this is, instead of, it's kind of like a dot operator, but when you're using pointers in C++, we use this notation. You can also access by, the access the value pointed to is test1.grades. And so it's the same as, it shows right here, accessing the value pointed to by test pointer arrow grades is the same as doing a dereferencing of dereferencing the test pointer dot grades. If I want to access the value, I can just dereference test1.grades. So remember, the pointer's the address. So this is basically if I undo what a pointer. So I have a dereference, and if I dereference that, I'm back to a pointer. These are basically kind of undoing each other. And that's the end of the slides. I will have another video that talks a little bit about a few programs and the program that you guys are going to be writing.